Might as well. I think I'm recording, but this time I'm recording properly, recording to the cloud. And if I go this, nobody's here yet. And then if I was gonna go too far. But please stay in the middle. Then we have Ahmad. There you go. Then I say instructor, then I have a preset. So audience. Audience is right here, instructor is right here. Okay, that sounds reasonable. And I'm gonna start sharing. And where am I sharing right now? I share this. So if I'm not mistaken, I'm gonna minimize the video, because of course this bumps right in front of me. So I will have a chat up. Then I will have the participants. And then I will have a share. So I'm going to control Alt Shift H. Then I'm gonna say this is the time. And this is the website. Well, of course, it's in the wrong place. So now type the whole thing. Okay. Let's see how that goes. Hello, how are you? There you go. I'll start with it. This is a time. Now. So this. Okay, apparently I can go in several ways. All right, that man. Please join. I'm going to.
Recording in progress.
Yeah, but I want to talk to you. I don't. No audio, but that's it. Excellent.
So I made the mistake that I could access.
Yeah, she told me. I said that she was better than Sherlock Holmes, House and me, and Lieutenant Combo together.
Yeah, she's great. Yeah. Absolutely.
I'm so happy that she, but you knew her from before, so you work.
Yeah, we were gonna say, we have our office in the same area, apartment.
Oh, I think pretty good.
My video life was one minute. Different.
I am so happy that now it works. It's kind of irrelevant because we're gonna do that in campus anyway, but
But still, I like it actually more, I don't like when I was much. Depends.
it is.
It
better
depends
to be in
how
charge.
people are using it. I have seen very chaotic classes from some teachers. I will not be particular.
This will become periodic quickly, but
I think this is quite organized from what I have seen from other classes.
that's not good. But I'm saying that regardless, it's actually very good to know that you are completely in charge and you have options, right?
Yeah. And you asked yesterday about the Cooper Quantum book. If you have a physical copy, I would love that one.
I was gonna ask you this,
Yeah, I have one with me right now.
that's fine, whatever.
Haha, you guys.
From its second.
Let's see, how can I distinguish which one deserves it? I
It's
have,
over.
It's okay. You think so? No, it's okay. I mean, for me, it's when you can flip a coin, that's a
so,
random generator. So
one good thing is that if I don't have it with me, then we're done, but I do have it with me. I could have brought pen today.
I would ask this year.
yeah, me too. So no,
So he asked first, right?
Yeah, yeah.
But Thursday I can give it to you.
Okay.
Did you come to this, right?
I won't this week.
You
Because
won't?
I have a family.
You-
on Thursday. So I'm here on
Yeah.
Thursday, so you get it.
Perfect,
Yeah.
thank you. Yeah,
Yeah,
I have to go to my grandma's birthday party in Minnesota.
Minnesota. So you're a Viking. Yes.
So. What time is it? What do we have to about 3 minutes? So I'm on seven now.
Maybe it will show today,
Show what?
but I have I made a notebook and I can save it to my Google Drive, but I wasn't able to send to my own GitHub, but not to the one that you made. I made a fork even. I cannot accept.
Don't make it 4. No, because it's gonna get very confusing. Also,
Maybe you can show this today.
I did show, no, I didn't show, but I did once for, I did show it with somebody. Sure, I would absolutely do it.
I wasn't able to put it really into this,
No
you know.
No problem. So then participants, let's see, let's first say who's here, I'm here. And okay, your name is John. Gruys.
Yeah.
But how can we go back? Let me see, I go to students over here. And that's you, that's you. And now I have to authenticate like yesterday, so let me minimize this, still have a few more minutes. Sign in. It's good. So I'm the owner of all those things, but then I am, oh, okay. So, because I did, I think I did sign up in it already. So please verify your device and I get this one here. But like yesterday, but in a few days, if I keep doing this, it's not gonna ask me anymore. So verifying, and that's your thing, right?
There is as well, you
Ah.
can somehow GitHub site, something that you have in the phone. And it stops as well as.
I'm not entirely sure if I gave you any kind of permissions. No, so this is a repository which I create. You have not yet told me anything and I haven't invited you and so on. But I do have one for here. And I'm gonna go back into where the pictures. So if I click here. You know, under settings, with what he told me yesterday, that's his name. And then when it comes to what I did already yesterday, Jack, for example, was here. And I made a demo for him and I put inside this thing.
Oh, you put.
Yeah, which we did in class.
Notebook. Okay,
And it's just very simple, but it looks so good. And today, I'm gonna explain in a second what I'm gonna do because I want 8:45. So I guess we should need to get started.
or is, in this case, I know what to do, how to do that, because I tried, I was in the column itself, and then you can save in GitHub, and then I could.
Oh, wait. That's better, okay, and it's nicer. But then you have to have your authentication streamlined. So I think you should. So there is a way to say, just put it in there, and that's
Yeah.
nice, right? And I say, don't even worry about it. Our approach is gonna be very low key, like take it, download it, upload it to the GitHub by hand. And it's just gonna stay there. I'll show you.
Okay, yeah, easy, now,
Yeah.
I mean, now it's everything clear.
So being 8:45, I need to get started. I'm gonna close this.
Yes.
And I am gonna say that yesterday I messed up and I recorded on the desktop. Which made me have to put it on the YouTube, but then I made it a short video. Which I did normally, and that was in Zoom. So I'm gonna come back to the class and I'm going to say here, escape. And I'm gonna go on the participants, and the first thing is we make sure that the participants online can hear us or we can hear them, so I'm gonna go in the side of chat. And I see online Ahmad, so I am online. Why am I not online from that? Oh, I'm also online as Adrian. That's my iPad. And then I have Alisa. And then I have Ahmad, as I said. So people online, they all have names that start with A. Today. So then I want to clarify that Ahmad made an appointment already, and that's excellent. Unless I made it for him, but I don't think so. So Ahmad is an appointment at 8 o'clock. See, I don't believe Ahmad is on our time zone right now. So I think he told me in last fall, I need to take this class, but I might not be in Bloomington. So that's all right, and I have no idea what time he has when it's 8 o'clock here. But as you noticed, I have office hours between 8 in the morning and 11 p.m. And this is from the time of the pandemic when I would have, which may be the case now. I had people all over the place. So this was giving me, if it does show up, there should be a picture over here indicating where it's night and where it's day. But I don't know, it doesn't show up. Well, there you go. So day right now is whatever you see here, and night is whatever is like the blue part. Anyway, so people who might be elsewhere, if they Korea, China, Japan, whatever, they can say, hey, can you meet at 3 a.m? And this could be, it could be that I can, but I'm all listed here. So it's not gonna be automatically available during the night. But if you need me during the night, I could meet you during the night. If we set it up that way. So I have an appointment with Ahmed on tomorrow. Tomorrow, as I wanted to clarify, there are no classes, but we have office hours. And now I'm gonna go back to this thing here under what's new. If you click on what's new, you're gonna say, I did post something for today, June 18, and they summarize the learning objectives for this week. And then yesterday I had this issue with the video not knowing if it's too long or not, you can't hear it, and I made a shorter one I posted. So now I'm gonna go back to what I said earlier. So participants, we also have Jack, that's very good. And so at this point, we have some people online. So let me ask a question in the chat. So usually I say, if you can hear me, write your name backwards. Could you guys do that? So if you can hear me, write your name backwards. I will start. And so this is how I write my name backwards. See how fast I do it. There's Ahmad, and then there's Jack with a lowercase j, and then we have that's almost Alisa, right? That's totally good. So great, people can hear me. I can hear myself, and Alisa and Jack and Ahmad are good. So you can hear me. Now, as you know that if you need something, you can write in the chat and I will be notified, or you can just speak up. And I think we did the test today and we are good. So anybody wants to say something, be my guest at any time, just start talking and I will hear you. Or type in the chat, I will be notified. So I'm gonna close the participants and I'm gonna get started today. So I'm gonna get rid of this. You guys online cannot hear me. cannot see it, but the floating controls are annoying, and so I just disable them. So I'm going to say that every time you go to this place, under these numbers, you will have information. For yesterday, we had information as to how the whole class looks. And then for today, I did, first of all, what we wrote yesterday in class, and then I have some targets here for the week. So let's suppose that people have trouble getting in and the Zoom cuts out and so on, then I guess they will have to watch the recording. Let's say that they are so busy they can't watch the recording and the recording seems so sloppy to them, there's nothing edited, right? And that I guess they say, oh, it's too long, can you come up with something shorter? So these are the things that I have a short video from yesterday, that's 9 minutes, but what if that is sloppy too? Then I'm going to try to put things in writing. And so I say, I would like you to please attend the lecture, the guest lecture tomorrow, not tomorrow, oh God. Tomorrow is 19th, so there are no classes tomorrow, but on the 20th, we have a guest lecture. And he's coming, this is only lecture from Mathematica, from Wolfram Science. I want to remind you that the structure of the lecture is in the first 15 minutes, we kind of connect with the past. And then the next 30 minutes are supposed to do the new material, and then the next 30 minutes are going to be something like a lab. So please try, if you can, try to attend, if you can, synchronously, the meeting on Thursday, because he's going to discuss, you say, well, what is it gonna say? What is he gonna say? He's gonna talk about teaching quantum with the Wolfram quantum framework. I have a lecture, I'll pose that. I have a lecture for the club, for the Quantum Technologies for Everyone club in February or something. And you can look at that. And then he's going to become more specific. So because we have 10 high school teachers which are sponsored by the Quantum Center for Quantum Technologies, it would be interesting for them to see in what way they could take Mathematica and use it in the classroom. So we are going to also go and do for Wolfram Alpha. Mathematica has a lot of functionality inside. I can give you answers very quickly and then sometimes tell you how they did it. That's what he's going to talk. 19 is a holiday, 20 is a guest lecture, 21 we come back here for one lecture for the week. And so if I click on 18, I said the goal by the end of this week will be for everybody to have access to their GitHubs. See, these are what the GitHubs are, right? And so I click on Emma already gave me the username. I clicked on John hasn't yet done anything. Jack, I did an exercise with Jack yesterday, and that's like the most advanced thing. I'm gonna click here and you can tell that there is a demo, which is exactly the notebook that we did yesterday, which wasn't that much, right? It was just one little program. Okay, now today we're gonna do everything that we wanna do for the week. And as I come back over here, I say, well, what exactly do I want from you? First, make sure that slowly we have access to that GitHub and you can post stuff in there. And honestly, there will be no requirement for you to actually post or do stuff. It's up to you. And if you say, I want to know, but I don't want to be forced to have to submit by a certain deadline, that's totally fine. And then you say, but I don't know how to do it, then I can help you with office hours. So it's up to you, but I strongly suggest that you try to upload stuff so you can show it to me, so you can say, I have seen this and here's where it breaks, here's where I understand. So the goal would be to create a Google Colab notebook, which I'm going to work on today. The way I do it is I'm already logged in some Gmail account, and if I say Google Colab, I believe that I'm going to get the one from yesterday, and that sounds fine. Well, I didn't say anything, I suppose, yesterday. That's fine. So a new notebook. Well, who knows who I was yesterday. And on title 4, there must be some history with me, but maybe I deleted it and so on. So this is my Google Colab for today. And I want to put as much stuff in here as possible. As I read what I'm supposed to do this week, clearly the goal was to establish a platform where I can do the work. I'm going to do math, and I'm going to replace the math in the beginning with the Misty State formalism. And I started distributing the books. And I'm going to, over this today and tomorrow, I'm going to email everybody individually and say, hey, is this the right email to talk to you? And by the way, when do you think you could meet with me Friday, Saturday, Sunday, Monday for the week before? And I will try to establish some set times for that. And then honestly, for the first meeting, the main goal is to establish how the weeks are going to go and how we're going to meet. But in the process, I also want you to actually be able to open a Google notebook Colab notebook and then put some stuff inside, some programs in Python for the probabilities, and then a simple circuit that only has one qubit quantum gates. I can identify very good resources for you on the web, and because we agree that the math seems to be intimidating, the benefit of this particular class in summer is that we are going to teach you the Mises state formalism that will actually formulate access to the math in a better way. But today, I would like to do this problem, 1, and then also 9, and I want to do each one in 2 different ways. Then I would like to remind you that we have to create a simple circuit, and the circuit that I would like to point out today is this one. So you can find this in the little qubitzer, and what you see over here is not enough to make the thing the way it is. So this is the X gate, which is not. This is the Hadamard gate, X again, not. Hadamard, not. We need to introduce them and we need to play with them a little bit. And in general, we need to be able to write down stuff on the on paper to indicate how exactly they function. Now, I asked you at the very beginning to actually go and establish where these resources are on the website. And I think I'm going to go there right now. In the video that we did yesterday, the super short one, the 9 minutes one, I said, all you have to do is to go to syllabus and you have the links. So as you scroll down, I'm going to say the little qubit is here. You scroll down, and in the process, I have a slightly complex circuit, which has 2 qubit gates that builds an entangled state. But again, the benefit of this, of the thing that I'm showing you is the part that you have at the very top. First, you have to install Qiskit, because everything that you do is free. So you can't possibly install today and see it there tomorrow. You have to install every time you go in. Then you're going to import the specific library, build a circuit, and then you're going to show it to me as a state vector. So everybody speaks the same math language, but we're going to start with Mises state formalism, and we always have to have the correspondence. Well, it's easy to trace with a Mises state formalism. Excellent. But then what does it mean? Is it the right thing? Is it the thing that Qiskit would give me or anybody else in the field? So as you scroll down on page 10, indeed, you're going to have the circuit that I told you, but only with the last part. I guess it's not page 10, it's on page, whatever it is, 16. So see, the part that you see over here is the part that says, give me the state vector, which in this case is -0. So it starts with 0, that's just a convention. We'll go over this again and again. And then at the end, you get the 0 that you started with, which essentially is a white disk, but with the face, which means that there will be a little horizontal bar at the top if you do it with Mises state formalism. So the qubit is really the guide. And in the book that I'm starting to do, today I started distributing the hard copies for the qubits for quantum. This is the website for qubits for quantum, and then if you have to watch this video today, tomorrow, the day after tomorrow, but definitely this week. And if you, as I said, if you click here, you get to see the book the way he decided to post it. Actually, this is probably better than my copy online. My copy doesn't say draft on it, but my copy is good too. Except I'm going to give you hard copies too. So that's where the book is, and this is what we're going to discuss. I told you that in the end, this is our goal, to go into the material that Martin wrote for the Schrödinger class that they had over there, and now it's changed. So instead of meeting in November, as they normally do, they are meeting in summer. Even this summer, they are meeting after our class ends. As I said, high school teachers from Canada are going over there. They're being hosted and fed, and everything is paid. But I think they pay the airplane. But other than that, I think everything is covered. And they have 3 days, and it's called Quantum Computing for Educators now. But you see that they also have a bunch of other things, such as the School for Young Students. And you're looking at this that says, I'm going to teach you math. And the good thing about this is there are lots of examples, and it's meant for people who truly want to learn this, but don't know anything. So it's a very dedicated person, young and whatnot, but truly doesn't know anything and wants to learn everything. So lots of examples. I'm going to say that another very good resource is Quantum Country. And I'm just going to come over here and click. And the title of this website is let's see, quantum computing for the very curious. That's the starting schedule. Now, this particular website that I'm going to mention again and again is also listed somewhere on our website. If you look at our website, where is our website? C298 Quantum. If you go in here, you see quantum computing for the very curious is listed over here. This is the Martin LaForest thing, and this is the collab, and I have other things that choose for quantum, and this is Terry, and I have a bunch of other things that I will talk to you about. And this is our next resource. Where is this book? And why is it important? So Quantum Country has an interesting thing that it teaches you just the basics, and it does it well. And there's two people here. One is a co-author to the fundamental book in the field. But now I'll share that to you as well. That's a book that was used in P555 last semester in the fall. And the other one is Andy Matushak, I think it is, was the Matushak. And then he has this idea that you need help to remember things for a long term. So if you sign up here, then he's giving you material and then he's giving you exercise, and mess up exercises that you get them wrong. He will email you at carefully selected times, interval of times, to remind you that those exercises have to be retaken. And they do this in such a way that by the promises by a certain amount of time, you just know that because they prompted you in such a way that there's no way you can't forget them anymore. And so there are some really meaningful parts in here. And this is the style that they have, like after a certain amount of time, there's a possibility for you to forget, therefore you're going to be prompted and so on. So it's an interesting medium that they set up. Really, really well put together, and again, for the very determined, but also the ignorant. I mean, and of course, smart, but ignorant, and that's how we are in the very beginning. So I'm gonna come back here and I'm gonna say, you know this, so where is the last book? And now I'm gonna ask John, just for the fun of it. John, if I find a book, which by the way is right here, why do you think I've chosen this book? What would be the main feature of a book to make it useful? What would you say? For a book to be useful, what would be the main top quality? I'm just curious if you guess the same thing that I don't know. You don't know?
Copy
Yeah.
commons,
What was that?
copy commons.
What did you say?
Copy comments.
Is that what you said?
Yeah,
Copy comments? What does that mean?
that means it's free and open source.
So free is important, right?
Open
Okay, but I can write something free and bad. And you're gonna say, see, so that's not the most important thing. Okay, so I could pay for something as long as it has a feature that I like it. So you say, okay, the content should be good. Yeah, the content should be good. Do you, when do you know that you know? If you read stuff, do you think you're just gonna know? I think if I read stuff, for me, high probability of falling asleep, thinking about this stuff. But how can I be sure? Learning has to be active. So what is it that has to be that the book, because the book is a good friend, but a cold friend. The book doesn't say, come here, you have to study. Let's do this. You don't know that. I should teach you. The book says, I'm here. Use me if you want. So what do you think is supposed to be in a book?
Have to chapter with how it's written.
Exercises. It has to have exercises. If it doesn't ask you questions, then it's not clear that you understand what they taught you, okay? So the main feature of a book, in my view, is to have solutions for all exercises. And so this is indeed a book for beginners, written by a guy who's extremely passionate. Then I can tell you more about Tommy Wong later, a very nice fellow. But the good thing about this, okay, so I proposed books to other people in the past. The first question from high school teachers normally, which I think is the best question, is totally legitimate, does it have answers? Because I don't have time to solve the problems first and then teach it, you know? And the books that I suggested didn't have any answers, but this one has answers. So not only is actually talking about quantum computing from the point of view of classical computing in the beginning, and I will give you reading assignments, but every time you have exercises, they are in fact solved at the end. So answers to all exercises, all of them. And that's, I think, meaningful. You don't have to, nobody says,
you have to provide the answers because nobody knows the answers. No, the key is, do you think you understand the answers? And so you can check yourself, or if you don't have the time, read the answer and say, I don't understand the answer. That's a good, important feedback. If you read the answer and have no idea what they say. And so you come back and read some more, or you ask me or whatever. So I have identified all the resources that I told you to look. Hubisa is there, Terry's book, and I give you Martin Forest and then Tommy Wong's book. So let's start with exercises that we discussed before. And now, normally I ask people, say, hey, what do you guys think? And how should we start doing this and so on? Okay, but I'm gonna pretend that that you guys already have given me the advice. So I'm going to do first problem number one. People can call me and stop me or ask me to do other things. But here's what I'm gonna do with problem number one. So it says you're gonna play a game of craps. Is you have two dice and you are going to roll them. And if you the roll is 7, you won. Otherwise, you don't win. If you always have to put a chip to play. So then if you lost, you lose the chip. But if you win, they give you 4 plus the chip back. So you have a win of 4 if you roll a 7, and you get a loss of 1 if you roll anything else. Now, as we discussed yesterday, there are 2 dice, so there will be 36 outcomes, and there is only 1 7. How many 7s do we have? 6 1 1 6, 2 of them. So 2 out of 36, then the chances would be 1 in 18 to win. So then the question is this fair? And if not, what does fair mean? So I'm gonna say that yesterday I showed you that you could, I think it was the other problem, and we'll get to it too. So yesterday I said I'm going to start writing a program that simulates me playing the game. Let's play the game for a large amount of time, like 10,000 times, and then let's look at the answers. So by the law of large numbers, I'm going to get something that is in the neighborhood of the right thing, and therefore I can draw a conclusion. And so yesterday, my conclusion with respect to that one was, what's the chance of getting not a prime? And it was like 2/3, and we did get that. But here's what I'm gonna do right now. I am currently, see, in a Python code cell. So this is an extremely good environment. And the fact that makes it good is that you could actually program in it lots of things, classical and quantum as well. And then you could also write stuff that reads well. But you have to switch between code and text. You can post it and it goes online, graphics or whatever it has, it's just going to be preserved. So I'm gonna click on this and I say, get it out. And then I'm gonna close this one also. I want a text. So I'm gonna say problem 1. This is text, right? Problem 1. That's the first problem. You say, well, okay. So the environment, because that's what I'm going to show you right now, is that on the left I write stuff, it's raw, and on the right shows me how it's going to show. So if I put a star around these things, then it's going to make it bold. No. So then what how does it make it bold? I have no idea. But if I make star, it's going to make it italic. 2 stars. Probably. So I'm going to say, fortunately, they have this and the 2 stars that I was told, and that looks fine. This is very non-standard. In other words, nobody else does it with 2 stars or 1 star, but this one does. And most of the other things are going to be just like in logic. And I'm going to say this. Let's say that for some reason, we're talking about the way to think about this problem, and you have an argument. Can you write the argument? I say, that's what I'm going to write first. And then I'm going to write a program that will support the argument, and I'm going to move to the next problem. So I say define fair to be as having an expected value of 0. An expected value of 0, I'm going to put here 0, because say if I play the game this long enough, so can I tell you, please don't solve this problem thinking? No, you could. Okay, it's up to you. I said, please solve it in 2 different ways. One would be write a program. The other one may be argument. And the other program, I'm going to say, don't do any, because we looked at it. Looking at all the cases might not be that convenient. So I'll write 2 programs for the other one. But clearly, when they do the misty state formalism, I like Qiskit to actually give me the output. And then I also want to be able to, and I'll start either today or maybe on Friday, I'm going to start drawing things for you to indicate how we can use that book and the formalism that he introduces, so to keep track of what's happening inside. Just like right now, I'm saying words describing what the probability problem should be solved at. So what is the probability of a 7? Now I want to ask somebody, anybody. 7 is, I made an argument, right? That 7 is 2 in 36. What do you guys think about my argument? Was it good? Did I convince you? Was I yelling loud enough to convince you? No, but at least I didn't say 1 in 36, 6, 1, but I have 1, 6. Are there other cases that generate a 7? Exactly. So the probability of a 7 is in fact, and I'm going to put together a fraction here. So this dollar sign is in fact a standard convention in LaTeX. And I'm going to say we have 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. So the fraction is going to be 6 cases, right? One dice goes from 1 through 6, the other one goes from 6 to 1. These are the 6 cases. And I'm going to divide by the 36 that I have. So then I say that's going to be 1 in 6. So I go again. You see how my logic looks on the right side, but I'm so happy that I can write math in a way that is expected of me. And if you move to Overleaf to write a paper, to go to a conference, that's the logic that you are going to do. Everything, any mathematical symbolic is going to go in there. So I say that's the probability of rolling a 7. Oh, that's nice. How am I going to continue my argument? And in this case, as I said, I'm going to every week, I'm going to solve the problems that I would like to discuss with you on Fridays or Mondays or Saturdays, whatever, at the end of the week. Because, as I said, I don't want to challenge you unnecessarily, because I will not solve them as soon as I state them. So you'll have a day or two to work on them if you want, without me interrupting. But I will solve the problem, and then the question is, do you agree with my argument and programs? And if you do, then I guess tell me during our weekly meetings. That's the probability of rolling a 7. You notice there's a difference. For example, if I want a 7 in the math environment, I put a dollar sign in front of 7. And that's a 7 that's not like the 7 that you had before. So you look at the 7 that it was before. That just is different one. All right, never mind. So I got this, and I'm going to say, what is the expected value? The argument here is not going to be too long, right? And that's the problem with arguments that go with math. They are supposed to be short, and if they are short, maybe I can convince you right away. Then you have to think hard. Then you may or may not convince yourself. Then it's good to have one other thing that says, I am showing you that you made a mistake, or I'm going to show you that you got it right. So the expected value is going to be this. What do you think about my formula now? Put $2 signs because I'm going to put the formula inside. I put a parenthesis, and I'm going to say 4 times, I'm going to put a C dot over here, fraction 1/6 minus, and then I have 1 times, and then fraction 5/6. So can somebody explain to me what I wrote? I'm going to put parentheses here. Does this look like the expected value? See the problem? If you didn't come up with this formula, if somebody gives you a it may be a good formula. You say, well, I'm not sure what you said. How did you come up with that? For example, John, what is the 4?
What you win.
Exactly. So the 4 is the money that you make. What is the 1 that multiplies 5/6? It's the dollar you lose, or cheap, whatever. So in 1/6 of the cases, you win $4, but in 5/6 of the cases, you lose $1. And so I'm going to come back over here, and I'm going to say this is going to be fraction 4/5 minus, then I have a fraction 5/6. Because it's just simple mathematics, and then I'm going to say, so the result is going to be a fraction, and what I wrote over there, maybe it's messed up. But there you go. And now maybe Elmar, can you tell me, is this fair or not fair?
It's not fair because it's 4/6 minus 5/6.
Yeah, also I forgot the minus. The minus said you're losing money. If you are a gambler and you come here hoping that this is fair, and you just say, I just want to run my luck, but here you're not, because the house said that we have to make money, otherwise, you know. How do we afford to build a building and then host you and give you drinks or whatever we're giving you? So the minus says you're losing. And how much money I'm gonna lose, that's the percent they're gonna lose. So this is not fair. Now you could ask yourself, well, maybe instead of 4, you know, which is right here, I need something else. So if I were to replace this with an X, then I would go and do the X, calculate the X so that the thing is 0. 0 would be fair. I mean, if it is fair, which they can afford, they need to have make some money. But if you are in fact going to make it fair, then you have to find the X that will be 0. And this is a simple problem, so I'm gonna put a 4 back, but clearly that if I had a 5, that would be perfect, right? So if they were to give you 5, plus your chip back, if you roll a 7, and by the way, there are 6 of those, right? Then the game would be fair. Fair would be, and I'm gonna say this here, fair would be with the 5 instead of 4. And so now, and depends on how you know, obsessed with details I am 5 instead of 4 away. So you could say, do I need to put the dollar sign and so on? And so if you, like I used to joke, right? I say I have CDO. What is CDO? It's OCD with the letters in the right order. So that's the joke. But hey, I might be so obsessed with details, right? That I even put the letters in OCD in alphabetical order because, like Mr. Monk, for example. But seriously, if you say, but I like them so much, then okay, put them everywhere. And there's no difference between a 4 and a 4, except they do look differently. And that's what I'm trying to do over here. So I'm done with the problem. This is acceptable, except this text. And now I'm going to say, now I need a code. I just wrapped up one way of solving a problem. It's always going to be possible to do this. You're going to argue and put some math in there. And I hope I didn't make any mistakes. So I started by making some mistakes and the minus and the things. So now how can I organize myself here to write a program that will indicate that this is not fair, but if it were 5, it would be in fact fair. So I'm going to do escape and I'm going to see who is here. So now I'm going to just mention the people online, just for the fun of it. I mean, Ahmad or Alisa or Jack, if they had an idea or they wanted to talk or show me or write in the chat, this would be a good time. If not, I could ask Elmar or John. And if nobody wants to talk, I'll just move on. That's fine. So Control-Alt-Shift-8. But now I hope you understand roughly what we're going to do on Fridays. But we pick some random representative problems from the things that I post for that particular week. And the theme for this week is co-op. You can do Python with classical programming or quantum, and we'll do quantum in a second. And quantum has to be supported by the Mrs. state, which then becomes the math, and then all the probabilities that we do could be math with words and nice math, like I just wrote the fractions, for example, and then I could write programs. And one thing about Tommy Wong is that I honestly will tell you more about Tommy Wong as we go on, but in his book is for the beginners, absolute beginners, and it starts with classical computing, and you guys know classical computing, basically classic gates, and then it says that's exactly the kind of stuff that we do in the quantum computation. At the moment, the leading paradigm is quantum circuits, and we go with those, and you just have to know the gates, and it's the same thing. So now I'd like to say I have the code, and I would like to confirm here that this is the calculation. So I have 2 options. I can do what I did yesterday, which is let's play the game. Meaning I have 2 dice and then I throw them. So I say import random. And then I say V1 is going to be a dice, so random random int 1/6. Good, and that's not behind int, but come on, man. Okay, yeah. So go back to where are you, cursor? Okay, that's one, D1 is a dice and D2 is a dice. And I want to say that now I should print the sum. So how about the sum is equal to D1 plus D2, and this is starting point is basic stuff. And I'm writing it, so I got a 5 the first time out. You say, well, it would be good to know exactly what the 5 is made of, so I say, okay, fine, print D1, D2, and then print the sum, so now I didn't get a 5, I got 9, instead of 3 and a 6. And then if I just do this a couple of times, I say 5, 1, 6, that's so on. So what am I gonna do? I'm going to play the game. How many times am I gonna play the game? It depends. I think just to do it like last time, I'm gonna say this number of times, which in the beginning is, what do I want to make it? I want 10 times. And say for I in times, okay, range of times. Then for 10 times, I'm going to, nobody needs I, but it will count stuff for me. I get 2 dice, I'm calculating the sum, I don't print anything, but why not print it? And then say, if sum is equal to 7, then I'm going to say wins plus equals 1. But otherwise, you say, I like the otherwise, but the otherwise is wins doesn't go up. So I say pass, if I really want to have that thing. Then, yeah, this is probably have to be too much, and I want to go, come on. Where's wins? Wins apparently doesn't exist, and that's why it was highlighted. So now I'm going to run this, and it says, look what's up. You got an 8 and an 11 and a 5 and a 4, and so no 7s whatsoever. And the way I'm doing it, I want to see what wins is, and that happens to be 0, right? So I say, you don't have to split it like this. Why don't you just print wins at the end, which I think is great. But really what I would like to print is in fact wins, I guess over what? Wins over times. So when I run this, now I'm going to say to forget the print anymore. I mean, it makes sense for me to print as I build it. And clearly 10 is not a good number, it's too small, so 0.2. Now the question is, what do I expect? This is a simulation, so it's not going to be accurate. I'm going to draw something, I'm going to write a program that will calculate the right thing, the actual thing in a second, which will actually say, looking at all the cases, I can tell you this. So it's kind of like formulating the argument, but with program. But this one is like we did yesterday. Let's just play it again. Okay, then I'm going to play it 100 times. And I get 0.27, and I play it 1,000 times, and I get 0.15. And then I get this 10,000 times, I get 0.16. So I wonder what 0.16 is. And I'm going to say 0.16 times 6 is 1. And then you remember that I was telling you that you are actually losing. This is a bias. So it turns out that if I print wins over times, and perhaps there must be a better way to argue, to convince people and so on. But what I expect right now, let me just quickly ask John one more time. If this were to be fair, what answer should I expect?
For wins over times. So 50. Oh wait, no.
That's what I would say. I'd like my wins to be
It depends on how much reward versus loss.
that's right. So we didn't do anything of that kind. So then knowing what, yes, sir.
I think it should be 0, right? Because you don't win and you don't lose.
That's correct. So I was thinking 50 sounds like a good idea. 0 should be like it. So that, but what you're looking at right now, so you guys both have right, you're right. My program isn't yet formulated correctly. And here's why. I'm not just counting the wins. I have to count the wins and multiply them by 4. Then I have to lose when I lose. And then that should be a 0. So then if I don't do that, I should get like a 50. Otherwise I should get a 0. So I'm going to say wins is going to be plus is equal to wins plus 4. I win 4, and I'm not talking about the chip that I got back. The pass here is going to be wins is going to be I guess wins minus 1. It doesn't have to be wins because now it's actually money. So I guess reward or whatever I want to call it. Money. So how much money do I make? Well, in the beginning I have 0, and this is going to say I make $4 every time I win. And then I lose $1 every time I lose. So what I would expect is to stay on zero forever, or close to zero. So money, minus equals 1. Now I say, just print the money. Except it would be nice to print the money over times to get an idea of what proportionally the money is. So I'm going to say money, and clearly, if I make money or lose money, then the more I play the game, the more money I will make. And I don't like the fact to look at the number. I want to see the number in the context of how many times have I played this. So if it's bias per game. And the more I play, the more I should see that bias. So the answer should be something like this. So this is negative 0.18. See that previously we get a plus something. That's closer to the expectation that we had. So if I do it 100,000 times, now this is 1/6. You know, I don't have to modify the number to get a different number. I bet I'm going to get something else other than 16.845 if I just run it. This is perfectly 16, and then this one here is okay. So if I say +1/6, if I do this, I think that will put me at 0. Okay, very close to 0. I said it's not going to be perfect. This proves that I'm calculating the expected wins in dollars, and the answer was proportionally you're going to lose 1/6. And I'm now going to say what should it be if I actually want it to be fair. So this is the program, and if I do it a million times, I think maybe that will be more statistically stable. Takes also more time. I proved my argument. It's very easy now to say make it a 5 here, and then you're going to be very close to 0. That would be fair. But fair in a simulation means that you're going to be in the neighborhood, really close to 0, but not exactly 0 unless you get super lucky. So the question now is, how exactly would you do this if you wanted to calculate the answer with absolute precision? Let me just remind you that our goal of this week is to work with this environment so we can be ready to create quantum circuits as well as classical calculations in here. All the quantum circuits are going to have matrices underneath. By the time we get to talk about matrices, we are going to know how to trace them with the Misty states. So the alps that I was telling you about. So then there will be more Python code in here. There's again, I have to give you those books. Of the books, let me go to Canvas very quickly. That I posted, which I'm saying there's no reading assignment from Bird or from Suter at this point, but matrices are like the only reason of being of that book, which is excellent, but from the beginning makes the argument that we should use the math. In fact, that's the subtitle. So if you come over here, and again, not everybody's in Canvas, but soon they will be in a week or two, whatever. And if you go on the resources, if you click on quantum computing algorithms, so this is a person that really like writes books for super beginners. I think he has some of the whatever for dummies. See, a little math goes a long way. And if you start reading on your own, not a reading assignment, he says, I decided that we have to teach math. And the first few chapters are basically on matrices. So right here. And he says, how do I do matrices? So use NumPy. And that's it. We can do matrices in Mathematica, we can do matrices in Wolfram Alpha, we can do matrices in other places. So there's no reading assignments yet from that book. Now let's solve the next problem. I mean, let's approach the problem in such a way that there is no doubt whatsoever about the answer. So I told you about quantum country, and I will make reading. I'll ask you for reading assignments. Now let's look at number 9. We solved number 9. The way I solved this one now, but this one also has a specific approach that is described in words that actually gives you the right answer, -1/6. So let's look at 9 and ask ourselves, how can I get the right answer, not a simulation? Because the simulations I set up, so everything is fair, okay, and then I write this thing and it's not 0, it's very close to 0, and always a different 0 point, whatever, like every time. So you roll 3 dice. what's the probability that the sum of the three numbers is not a prime number? I don't want the simulation, we did this simulation yesterday, yes.
You can go through each of the cases.
That's absolutely exactly right. So because I don't show whether this is a microphone, so maybe the microphone picked up exactly what he said, but in case, do two microphones, 3, 4. Okay, so maybe everybody has heard you, but if they haven't, then this is a answer. The answer is, let's go and write all the cases. And now the question is, if I solve this problem this way and it's good, looks good, and we get the right answer, I wonder if we can solve the first problem in the same way. And I'll leave that for you to think about, and maybe we'll talk about it on Friday, but I'm not gonna do it now, because I did it 2 ways anyway.
Mhm.
So let's go through all the cases. The cases are gonna be something like this, or D1, that's 1 dice, in range of 1, 6. Okay, this is gonna take all the 6, I'm gonna say print D1. I have a dice and I throw it. And I mean, not throw it. I'm not throwing it because I don't know what happens if I throw it. I'm gonna have a dice and I'm gonna show you every face of it. So this is gonna print 1, 2, 3, 4, 5, 6. But what I'm going to do is I'm gonna say, sorry, I have to consider all the cases for 3 dice. So then in my approach of developing things in stages, I'm gonna say, well, let's now consider the second dice. And I go 1, 6. And now I'm gonna print both of them. So I'm gonna say print D1 and D2, and what do you expect? And you're gonna say, well, I'm gonna expect 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4. So I have 36. And that's all the combinations for 2 dice, but we have 3 dice. Well, I understand now how it works, so I don't need feedback, although feedback as I put stuff together is actually quite meaningful. So I have a third one. I say 4, D3. In range of 1, 6. Why don't I print D1, D2, and D3? Oh, and that's gonna be 6 times 6, 36, 216. Hey, nobody's gonna hurt me with this. So 216 lines, very long, but then I just 1 click and it disappears. So sure, let's see it. All right. These are the 216 possible combinations of 3 dice. I mean, more than 200 and so on doesn't make sense. And watch what happens. I have a mistake. Can somebody explain what the mistake is? This would affect the answer. So when you look at what I'm doing here, I did not take into account that when you go from range 1 through 6, you don't ever get to 6. You stop at 5. Yeah, so I'm going to go and say go to 7 because 7 is not going to be taking, and now and then I'm going to say, okay, I can print them all, but that's not bad that I print and find any little mistake. But then I'm going to say, how about the count here? The counts, because at least I can say calculate them and should be 216. So what we found out right now is that this code looked good, but it never takes 6. So count is basically 216 right now, okay? But if I were to do what I thought was okay in the very beginning, and that was okay, but not completely, this would be 5 times 5 times 5, 125. But that's a significant difference from 216 to 125, and you see how it looks good, and it's not the right thing. So as long as we try to keep little things from interfering with us. I mean, little thing here is like half of it. Almost half of it is gone, right? That can't possibly give me the right answer. But as long as I understand what I did and I fixed it, and now I have all the 216 cases. So what am I going to do over here? I'm going to calculate the sum, which is going to be D1 plus D2 plus D3. Okay. And then I'm going to have to calculate. Yeah, I don't want. This guy is helping me so much that I can't do anything. So Control Shift H. And I come back to this thing, and what I did over here is to put the 2 problems and the footnote for the second problem together as if there's nothing else on the page. So when you roll 3 dice, the prime numbers that you get are 3, 5, 7, 11, 13. So 3, 5, 7, 11, 13, and 17. I come back over here and I'm going to say, if sum not in 3, 5, 7, 11, 13, and 17, I think it was, then I should count this. Okay, so count goes up by 1. Else don't count it. And now the question is, why should I put pass? You know, maybe I forgot something. So I like the fact that I put pass because last time actually there was supposed to be something there. We're supposed to lose a dollar and make $4 on the other branch. Here, probably the pass will stay forever. So it doesn't bother me, and it's up to you. But it's there to say you really have a branch which you're not using, which is, I guess, the way it is. So the count starts at 0, and I go through all the cases, and I only count when I find a not a prime. Now I also understand that there are 216 cases. So my goal right now, I had this written from yesterday. What is the answer to the question? No, I don't have it yet. Somewhere else, 143, I think. God knows, but I wrote it somewhere. I wrote it somewhere, but I don't have it. I 143 over 216, I think was the answer. Because I took this problem from Jim Frericks, and I showed you yesterday in the video, you see how I went to the answer and then the explanation how it works. But I think it's 143 over 216, and it's kind of like 66%. So I'm gonna say print, please, the count. So if I'm not mistaken, it should be 143. Great. That's exactly how many cases we have where the sum is not a prime number. But did you want that or did you want the probability? So the answer is now multiply by 6 times 6 times 6. That's the answer. That's the answer that we had. Great. So now we solve the problem. We have solved the problem by looking at how all the cases and then identifying the right cases and say these cases are not biased. They will show up with an equal likelihood. And as a result, I can tell that 143 cases over 216 total possible cases is going to give you a probability of 66%. You can multiply by 100 if you want, and that's it. But that's the thing. Now it's now 9:37, and I have only one thing to do. And then we can take questions or do other things. But hey, this would be a great moment for me to save this to show how to upload it somewhere. And to be completely honest, it's perfectly fine if you save frequently. Because it would give us an example as to there's a history on the GitHub, and you will always be able to go back to the earlier version. And if we look at the instructors, we look at the things that you post, and we get an idea to see whether you did them and how you thought about it and so on. And it's good to store that there. And if you get stuck, then because they are listed in your GitHub, you can call the instructors, and the instructors remotely can actually access them and make changes and put it back. So I'm going to show you how I can post what I have so far. And then at the end, I'm going to post the remaining file. So I'm going to go C290 quantum, and I think there's where is it? Okay, that's the class. Now I'm going to click here, and I'm going to go into students. So you know I have these fake ones. Now for some reason I think mine is private, because when I was creating them, I forgot to make it private. But I have Gru, for example, Stuart, they're public. So let me put stuff in Gru's account. So first thing, I'm going to say, what should I put? And I think you should organize yourselves. So what would be a good organization? I think by week, because the class will give you a grade if you are a student, and the grade is going to be an average of 6 numbers, and each number will represent how you did in a particular week. And you get a number for our discussion. And my goal is to make sure that you get 100 per every week. So I can give you 100 just because I have this goal. But if we talk and you either explain stuff to me, or I clear up things for you, and I get this feeling that you understood what I just told you, which I can check the week after too, then you get the 100. So this is not supposed to put pressure on you. It's just to make sure that the information keeps traveling to you until it's there. So I'm going to say add file. I'm going to create a new file. So I'm thinking I'm going to create a file called week 1. Okay, I could do this. You cannot create a folder that's empty. So you have to create a new file into a folder that doesn't have anything else in it. So I'm going to say this is for my week 1. And there's a thing at the bottom here, there's another bottom, so the top is just commit changes. Sure, whatever. So usually it comes with some annotation, and if I'm in week 1 already, but if I go back at the top, there's a week 1. How about I create another file for week 2, and then I say I'll do 3, 4, 5 later. This would be week 2, but I mean, if we define our interaction with our GitHub on a weekly basis, then you only have to have 6 folders. Then you can have subfolders if you want, but at least so I know which week is when. So then I'm going to say again, I cannot create an empty folder, but I can create a file in a file that doesn't have anything in a folder that doesn't have anything else. So this is for week 2. I was just going to say now, let me just put more stuff. For example, June 17 is when week 1 starts, but I want to be sure of the dates for week 17, 24. And then when does week 2 ends? Just put some dates in there and make it a readme that's longer. 24, 25, 26, 27, 28. So I'm gonna say June 28. So hopefully that's correct. 24, 25, 6, 7, 8. 5 days per week we meet, and there's a commit changes, and it doesn't make any difference, except you will see the readme when you access this thing. So if you go to week 1, the readme is there, week 1, and then if I go to week 2, then I get to see this thing with the date. So it's slightly different, and I get to customize it. So in week 1, I'm going to say, time for me to, I don't have time to go, I have to sleep, whatever. Then put stuff on GitHub just to have it there. And then wake up, I'm ready for more, then update stuff and upload it. Just make sure that it makes it as soon as possible to the GitHub so that we can see if you need help and you don't lose stuff. Well, now where is it? So this is in Untitled 4, and I can just change it. I'm going to say, might as well call this one, something. What should I call it? I'm going to call it Tuesday because it's Tuesday today. So then I have this, and I'm going to say file, download. Where is it going to download? It's going to download it on as a notebook. Don't download it as a Python. In the downloads thing. So it's over there already. Click here to find out where it is. It's a Tuesday. Now, what Tuesday? Well, it's in week 1. So that Tuesday, there's only one Tuesday in week 1. And then I come back over here and I say, I would like to upload my Tuesday in week 1. Then I say add file, upload files. Click, and this one says, what file do you want to upload? My Tuesday. Tuesday is not finished, but I'll finish in a second. So what do I want to say? This is first 2 problems. I can indicate roughly what it was. And then I scroll down and I say commit changes. And uploads it. And if I go back, Gru's folder, week 2 is still empty. But week 1 now has this thing, Tuesday notebook, which basically has exactly what you expect. All the nice math that I wrote, any kind of math, but just fractions now, and then 2 programs. And it's exactly as I did it when I did it. So then I don't necessarily need to rerun this. So if I want to rerun it, I download, upload, and work with it by myself. So now I'm going to say, I'd like to do one more thing. Again, you can stop me at any time, but what was the goal for this week? The goal was after I identify those sources and I go to the guest lecture because it's important because this guy is really good and it's the only Mathematica thing. Then I would like to solve 2 problems, which you saw, but I also want you to do this circuit, right? So let's do this circuit, see how it goes. Our goal, and so if we do the circuit, we're finished for the week. But to know where we're going from here, honestly, at the very beginning of the week, next week, what I would like you to be able to do is to get a diagram like this and prove it. So this diagram says if you start with 0, x converts it to 1. But if you start with 1, x converts it to 0. In other words, those lines are in both ways. So there are 3 gates in here, C, H, and X, which we have to define. And there are 4 values. There's 0 and 1, which is the qubits in computational basis. And then there's plus and minus, a base that is rotated with 45 degrees. So once we understand what these guys are, plus and minus represent the base because they are orthogonal. They're also orthogonal. And then 0 and 1 also define a base, different base. And then I'm going to tell you something about Tommy Wong. He has a game in his book, which you can get for free, but you can also purchase it. It's called Qubit Touchdown. So when he presented this at the Quantum Qiskit Educators, whatever, for IBM, he started by saying, you really have to pay attention to this game because when I was little, I got an award. And so he showed his award. He got first place in recess. I mean, how many people get an award for how they deal with recess? You know, usually because you run faster when you do math. But he was good at recess. And the reason was he would organize the other people to play meaningful, interesting games during recess. So he says, therefore, I have the credentials for you to pay attention to my game, Qubit Touchdown. Now, Qubit Touchdown simply says, take the block sphere and become aware of the convergence between the three bases that exist over there. And so we'll talk about that later, but plus, minus, and 0, 1 are two of those three bases. And there's no block sphere right now. So how easy is it to do this? The answer is first of all meaningful and interesting, and it's also easy depending on how you want to do it. But we will first do it not with numbers, but with Mrs. States. Who else in the world has Mrs. States? Nobody. 2000. I mean, there are some people I can name them. Okay, so at the University of Chicago, we have Diana Franklin, for example. She has 2 courses on ethics. At Virginia Tech, we have Sophia Economou and Eddie Barnes and a few other people. And so that's also for high schools. So people who are friends with Terry Rudolph basically have adopted this strategy, and they've done a certain amount of it, right? So we took it to the extremes in the sense of saying this is where it stops, and this is where you have to start converting to actual math, which is, by the way, the goal. So if I say that not many people use the Mrs. State formalism, I say it because you can find a lot of meaningful materials that are in the conventional math. This is an example. Andrew Helwer, this is Helwer. He's from Canada.
I'm applying for residency right now. Ceremonies again been a lifesaver with my application.
Oh, thanks. I will.
Welcome to Quantum Computing for Computer Scientists. Happy Valentine's Day. We will learn about this most romantic of all subjects, quantum computing.
This is a talk aimed at computer scientists. We will not go over very much, if any, physics during this talk.
So exceptional talk. This is from 2018, apparently, and the only problem is that he uses the standard formats. Absolutely no problem, really, except for the fact that we have a better formalism than he has, and it would be good to learn them both. So if you were to watch this, just want to warn you, that's more than what I want you to watch. But the first part is perfect for where we should start. So
you may have heard the phrase spooky action at a distance. This is
okay, now there's a video which is there, and here are the slides associated with the video. And what I would like to emphasize, you may watch this or not, doesn't matter, but after he does the introduction and he actually introduces the major operations in a very, very convenient way and intuitive way, but we're going to go slowly over this so on. He actually says I could work with single qubit circuits by using a state machine, which I haven't seen anyone else. And after you go through this, forget about this, but it's meaningful. This is a state machine. This state machine is for the X gate. This state machine is for the H gate. And he puts them all together. And then he says, please don't forget that the red transitions are going to be X transitions and the H transitions are going to be yellow. So if you put everything together and you start in 1, 0, which by the way is the qubit 0, say, well, how can I remember that the qubit 0 is 1, 0? Well, think of it as a vector. And if it is a vector, the top one is the 0 element of the vector, and the next one is the 1 index element of the vector. So 1, 0 is always going to be 0, and 0, 1 is always going to be 1. And it's a very simple convention to remember which vector is 0, which vector is 1. So 1 on the 0th position in the vector says that's how we mark 0 with a bracket. So then if I start in this position over here, where is 1, 0? Right here. Then I want to do the X. X is red. I move here. And then with the yellow, I move here. And then with the red, I move here. And with the yellow, I move here. And with the red, I move over here. So clearly at the end, I have negative 1, 0. Really nice way of saying, forget about anything else. Okay, so I did the same thing. I said, this is an important, a really important technique. And that's what he's using that I just told you. And in the qubitser, you see the same thing with misty states. Absolutely exactly the same thing, only when we start the misty state formulas, you see that this is a little bit better, easier. There are no numbers, there's no vectors, there's nothing. The basic idea, yes.
Could you go one slide back to him, because is there not one state miss, yeah, the last one, which is the
This is
when
X.
the attracted? Oh, now I see it at the top, yes.
Yeah,
Okay,
so
yes,
this,
yes,
so
I didn't see yellow, yeah.
So here you
Yes.
go, then from here you go here, or from here you go here, so. If you put yourself in any of these states, these are not all the states, but these are the states that make sense to start with and to calculate stuff.
Yeah, okay,
This is plus, but for
Yeah.
example.
I
this is
saw what
plus.
I,
So any state on this circle, yeah, you will go somewhere, maybe stay in the same place and so on. I have the same thing, and the idea again is to put them together. So all my not transitions are gonna be with red. All my, so that's another thing, we have to start reading the book, but first you have to watch the video. The video says Pete boxes, because Pete Shambo put together a lot of Hadamard gates. And so Hadamard has too many things named after him because he was bigger than Pete, but actually, Terry had to go to a group of middle school students in London and explain to them the basics. Clearly, he had this was people in the summer school that Pete had organized. So you don't go with Hadamard in that room. You say Pete, because Pete is in charge of everybody. Say Pete boxes, and that's how it made it into the book. But Pete box is a Hadamard gate, and we can see at the end of the book. It says Pete box such as Hadamard gate, and then a bunch of other things are whatever you expect that to be in a conventional set. So you have the transitions over here, where the blue ones are Hadamard transitions, and the other ones are not gate X gate transitions. So now the question is, how can I put the circuit together? And I want to do this because otherwise I'm going to run out of time. So I'm going to say Control Alt Shift H. I want to do it fast, right? We can do it slowly too, but it's better to do it. So go to the qubitser. Where's my qubitser thing? And this is a picture, so I'm not going to be able to take this. I have to type it. So what exactly can I put together? But it's not going to be hard. So the first example of a circuit that uses quantum gates shows up here when I say, watch out, because this is how you do entanglement. And hey, you need to know, and hey, it's going to be useful. So under my Tuesday, come on, get out. I'm going to come back over here and say, the little qubitser is here, and then this is my thing. And I'm going to come back over here and I'm going to say, please allow me to show you how you can put together the quantum circuit. The first thing that you do is, I don't have Qiskit, right? So if I say import Qiskit, it's going to say, what do you need? Right? I have no idea what Qiskit is, so I have to install it. Install it, and it will only be available for my session right now. So do pip in the collab, and you say install Qiskit, and also I want you to install the Pi Latte module. So then this takes a while. Everything is coming to me over here. 9:53, we have 7 minutes. We'll get this done and everything will be good. And then we're going to put together the circuit. Now, when we do the circuit that you see over here, it's still being installed, which take another 30 minutes, 30 seconds, I'm sorry. Then I will explain how you put together the gates one by one based on this thing. And then at the end, I say, but I could ask Qiskit to do the calculation for me, and then that would be great. So hide output and come back over here, and I'm going to say from Qiskit. And now let me do import Qiskit because now it's going, nobody's going to complain. See? So sure, you want Qiskit, no problem. Except I don't really want to do it like this. I say from Qiskit, which is quantum information science kit, right? So in Python, actual quantum circuits, but they're simulated. As long as we don't have a lot of qubits, that's going to work fine. And our goal is going to be to work with small number of qubits to understand what's going on. And then when you get to bigger, you can just send them over to IBM. How do or anybody? Like I said, there's at least 60 companies that can help you. So from Qiskit, D-Wave, which now I started building great model computers because they only had adiabatic computing. So from Qiskit, import the quantum circuit. Okay, so then you can use the qubits this way. And I say, all right, now I have quantum circuit. Now let me create a quantum circuit, except I'm not gonna do one with 2 qubits. 1, 2 circuit. If I do one with 2 qubits, you know, I could then say, draw it. Okay, I'll draw it, and I see if it's a circuit that's empty, it has 2 qubits, there are just 2 little things. So I'm gonna say QC, draw, and then I say output should be matplotlib. So MPL. Okay, look, my draw is saying you have a circuit that's empty, it has 2 qubits. Okay, good, but I don't want 2 qubits now. I want only 1. So there's only 1. And what am I going to do? Remember what my image was, whatever it was, come on, my mouse always gives me trouble here. If I say this is a circuit I would like you to do, well then fine, let's do an X first and then an H and X and H and X again. So I'm gonna come back over here and I'm gonna say QC, that's the quantum circuit that I'm building. We call it U or something, but put an X on the 0th one, because that's the only one. So X now shows up. And then I say, will you please put on the same one, there's only a 0 qubit, right? H, X, H, X again. So then the circuit that I'm building is going to have these gates, which we do not understand yet. But there you go, we built a circuit. And what I wanted you to do with this circuit is to show me what happens. And now I can actually use this. So once the circuit exists, and I call it QC, as you can see it over here, then I can get the state vector from about this guy in the Qiskit and say, show it to me. And remember, the goal for here was I put a 0. That's it. If you don't put anything, that's a 0. So 0 comes through X, becomes 1. 1 goes into H, is a different kind of superposition, and you get something, apply X to that. You can trace everything, and in the end, you get 0 back, but with a phase. And the answer should be -0. So I will do it as follows. I say from Qiskit quantum info. Import state vector. And I say, well, let me see if I type something wrong. I didn't type anything wrong, except nothing comes out of this. So then I want to say, give me the state vector. So you say state vector that from instruction QC, put it into some variable. I'm just going to put in A. You know, I think it's better to call it SV, but just so you understand, you can do any variables that you want. So I'm going to say over here state vector, which I imported from instruction QC. So state vector from instruction or QC. So QC is the circuit that I just talked about. Actually, I don't want this separately. I just put it in. I want them to be in the same thing. So A is over there. It says, well, there's a J over here. You're going to make mistakes too, so fine. Now I don't have any problems. So please draw, but do it in LaTeX. LaTeX is the thing we did at the very beginning where we had meaningful, actual, good-looking fractions. So this was going to say, oh, I'm going to draw everything. So I'm going to say A, because that's what I did. I say draw, and then say, please do LaTeX. Okay, so look, it comes up with a -0. So if I wanted to write the -0, I would take out the, let me go over here, say, what if I want to do the -0? So this is a very small thing, but I have already shown you how to do LaTeX. So if I say, if I want to do the -0, I'm going to say $, inside, put a minus, then put this, put a 0, then put right angle. And that's the -0, see? So I can do it too by hand, but this one says, I'll calculate it for you, and then I will print it for you in LaTeX. And that concludes our week, basically. I mean, the exercises. And so you could say, what I have to do before it's too late, I'm going to say, download this. Remember, this is Tuesday. Come on, download the notebook. It comes back in the same place. Oh, man. It's a potential spam. Hello? You have the wrong number. So it's now 9:59. It was spam. Okay, and I'm gonna say this is a Tuesday. What is going on? I need a new Tuesday. So where's my GitHub? This one is the GitHub of Gru. Gru has put something together in week 1, and Gru says, I got more stuff. So go into Tuesday and take Tuesday and put it over here and it says, but you already have one, so replace the file. And I'm just about to say that I finished all the objectives for this week in terms of what you really need to sort of understand. This is the kind of stuff we're gonna talk about in our weekly meetings for this week. So I'm gonna say add file, upload files, and then take this guy, put it here. It says includes quantum circuit. And then I'm doing this so I can show you that I've done this twice, and this goes in, and when you look at it, it's the new one. But if you also want to click on history, you will see everything you've done. So this one is the two programs that we discussed, actually, the text and the program, and then, you know, the stuff that I thought I didn't hide it, right? I didn't delete it, I just hide it. So this is the thing that we did together. Now, if I come back to week 1 and I click on history, you will see that I have uploaded twice. And it says, first thing you did read me, and then you said the first two problems, then you did include quantum circuit. So if I just want to see the notebook from 20 minutes ago, I can click here. And I get into week 1, so I go back in time and click on Tuesday, and there's no quantum circuit at that time. So the history is perfect and allows you to go back in time if you want, and allows me to see how it was before maybe something got bad and you want me to help you. And that's basically the end of today's class, and thank you so much for your patience, and I wonder if anybody online has questions. So anybody online has any questions? We are ready to stop. I guess we don't have any questions. Anybody in this room has questions? Who is in this room? We see right there is Omar, and then right there, John. We don't have anybody else in the room. Online, we have Ahmad, Alisa, Jack, me, and me. Oh, in the chat, let's see. I do not thank you. All right, well, thank you so much. If nobody else has any questions, once again, thank you. And this video will show up around 1:30 because I have to go somewhere and come back. But this time it's gonna be very easy for me to post it. If I can post it before like 11, I'll do it. All right, that's it. We'll see you on Thursday for the guest lecture, but in between today and Thursday, I'm going to email you individually to try to convince you to give me usernames for GitHub and also to set up a time to meet for the weekly meeting. Thank you and have a wonderful rest of the Tuesday. The audience like that. It's you from, and then questions of my.
Privacy.
Yeah, that's right. Okay, thank you. Stop. Yeah.